Okay, in this video we're going to take a look at past paper example 2 of quadratics. The equation x squared plus m minus 3x plus m equals 0 has two real distinct roots. So before I go any further, I'm going to underline two real distinct roots, because for me that tells me something about the discriminant. That tells me that my discriminant b squared minus 4ac is greater than 0. Okay? I want to determine the values for m. So pick out the values of a, b, and c. A is equal to 1, b is equal to m minus 3, and c is equal to m. Put those values in, so I get m minus 3 all squared minus 4 times 1 times m is bigger than 0. Let's expand and simplify. So I get m squared minus 6m plus 9 minus 4m is bigger than 0. So that'll be m squared minus 10m plus 9 is bigger than 0. So I now have a quadratic inequality to solve. To do this, remember, I go to my side and I solve for the equality. So I'll solve for m squared minus 10m plus 9 is equal to 0. So factorise this. That will give me, open bracket, m minus 9, m minus 1 is equal to 0. So that will be m is equal to 9 and m is equal to 1. When I solve a quadratic inequality, I always want to sketch the graph. So it's cutting through the x-axis here at 1 and at 9. Sketch the graph out. Remember, I don't care about where it cuts through the y-axis or the turning point. I just want the shape of the graph. It's a positive m squared, so it's going to be a happy face. And I want to know, when is this graph bigger than, when is it above the x-axis? So it's going to be whenever, before it gets to 1 and after it leaves 9. That's whenever it's bigger than 0. Bigger than 0 means it's going to be above the x-axis. Less than 0 means it's going to be below the x-axis, because that's what the y value is. So the bit in red tells us what it's going to be. So it's going to be whenever x is less than 1 and whenever x is bigger than 9. Okay?